All right, welcome back. We're back with our caterpillar for part 2. Last time we kind of did a pass of the base model, and today let's get into our first pass at the animation. So I'm thinking we can just get right into that. I've got sort of a warm-up exercise in mind, and then after that we can go to the whiteboard and really like hammer out the details of the animation. But so let's just get into this. Here's the material for this. So we're gonna have to create like a custom shader for the custom vertex animation, right? No, because look, we've got this caterpillar checkbox on our PFX lit surface now. So what's that? Let's check that. We can see it's doing some kind of like motion here. And if you come over to the shaders folder, we'll see that there's this caterpillar shader include now. And so let's open that up. And looks like if you delete this, then this will stop moving. So this isn't a vertex shader per se, but these functions are controlling these offsets that are being applied in a vertex shader somewhere. And so what happened was between lessons, and we'll actually drop this as a bonus lesson at the same time as this Caterpillar Part 2 lesson. If you're interested, we converted this PFX lit surface shader into an Uber shader that's got all these kind of fun properties to it, but it includes the fact that we can now sort of get going with these effects a little bit more easily. So check that bonus lesson out if you want to learn more about that, but for now let's get started with this warm-up I mentioned. What I'm thinking of doing for that is we've got these like segments on the caterpillar, and I think for our animation we're going to want to be able to control these individually. So let's figure out a way to do that. So I think the first thing we can do is we can try to come up with like a segment T that will go from 0 to 1, not like across the body of the caterpillar, but like within the segment. So each of those segments, this will go from 0 to 1. So we can start off by taking our UV texture coordinate, which is coming in just like the same way it's coming into our vertex shader. And let's multiply in our number of segments, which I believe was 6. And then we can get like a segment ID from that by just casting that to an integer, like just throw away the fractional part. And then if we subtract that off from our segment T, that should now give us the segment T that goes from 0 to 1, right? So now let's see if we got this right. I'm thinking maybe we can just move these up and down like an alternating pattern. So like if it's odd, we'll move it up, and then if it's even, we'll move it down or something like that. So we'll say offset Y equals seg ID mod 2 equals 0. So that would kind of tell us whether it's even if it does equal 0. So we can move it up, and then we can move it down if it's odd, let's say. And then we can multiply that by a sine wave of time, let's say, just so that we can kind of see that separating and coming back together. And then in this new pattern, let's just take this world space position dot y and add our offset y to that. So let's take a look at that. Okay, so we're seeing something happen, but I don't think it's doing the segmentation in the right place, right? Like right there. So the segmentation's not matching what we want to see. What's going on there? And if we come down here where we created those segments, we'll see frequency's 8. Well, I thought it was 6. Well, yeah, I did that intentionally, okay? I created like a little trap here. The number of segments is a property of the model, right? We shouldn't really be hard coding that in the shader because the model's procedural. We might want to change that number of segments. So let's do this as a shader global, kind of like what we did with the light. We can pass in shader globals, so we'll say like n segments, and then let's just declare it here. And then we'll have to like create a script to send this over. So let's do that now. And you might see here like there's no more segmentation just because that shader global is now 0 by default. So let's create like a caterpillar controller. And eventually, like let's say you wanted to add like an interactive effect to a vertex shader or something like that. This would be very useful for doing that type of thing. For now, we'll just use it for the number of segments though. All right, so just like what we did with the light, let's have this execute always, and let's set on our shader globals. I've still got that on the clipboard, I think. Yep. And then this was coming from something called wave radius multiplier. We can call this segmentation source. And I think this was frequency. Okay, so even though this value is stored on the wave radius multiplier, it doesn't really make sense to set a shader global from that script because it doesn't really know what it's being used for. We should only do that from a more specific context. And then just make sure that this is not null. so we don't get some error spamming if we haven't assigned that yet. All right, so let's come back to our scene. And on the caterpillar, this is almost getting like kind of bloated with the number of scripts. So let's make this the base mesh. And then we can create a parent. We can call this thing caterpillar. And let's add our caterpillar controller to that. So this will be kind of like a higher level object. And let's drag this over. I think it should just work. Okay, so I think the segmentation is happening pretty much the right place. Now, I am seeing this thing here, which I believe is because this must be where the V texture coordinate is equal to 1 exactly. So that's kind of wrapping around to like an invalid ID. So let's just fix that. Let's create like a maximum segment ID, which would just be this minus 1. And let's make this the min of our max segment ID. And what we've got already. And let's see if that fixes that error there. Okay, yeah, nice. This is looking pretty good. So the last thing I want to do before we head over to the whiteboard and start planning the actual animation is let's just play around with this and make sure that it actually updates if we do want to change the number of segments. So it changed the animation. We didn't update the mesh yet though. So if we update the mesh, we can see if we make 6 segments, okay, now that is working correctly. And let's try more segments. Let's go to like 12 and rebuild the mesh. And so that 12 segments is working. And I think this actually looks kind of cool. So let's try our animation with this. All right, so we're back on the whiteboard and let's now start planning out this animation. I think it's really good that we actually started separating those segments because I think what we want to do with this animation is we want to see each segment moving individually and pushing the caterpillar forward in this like cascading motion from back to front. You'll see that if you look at that reference that we're using, and I'll put that again in the video description. We're not going to try to create like a realistic copy of that. We're just using that as inspiration, but you will see these segments moving individually. And as they're doing that, they almost have like this jump motion where it moves up and then down as it's moving forward, which you can see if you really study the top of it, especially closely. The whole body will do that. It goes up and then down. Okay, so now how are we going to take that idea and translate that to code in our vertex shader, right? Let's start with like a simple metaphor, which is like an animation clip. So we can think of the whole like crawl cycle of this caterpillar as an animation that starts at the beginning, plays at the end, and then just goes back to the beginning. And we can like say that it starts at 0 and goes to 1, you know, my favorite range, of course. And so it will create like almost this sawtooth like pattern, right? It will kind of go like this, 0 up to 1, and then immediately back to 0, right? That's kind of what we want to create. We want to have some type of representation of this idea in the vertex shader. So let's come back to our shader code. This is our debug sort of code here. So let's just delete this out. Now we can still use this offset Y maybe as like a debug visualizer. So I'll keep that for now. We can create something called like move progress T, let's say, which will tell us it's going to be like this 0 to 1 range. That will give us the progress of the overall move. And we can take our time and then we want to like divide this by some kind of duration. So we can say like move duration, and let's just say it's like 2 seconds. Okay. And so that should give us that 0 to 1 range as we're getting up to this duration. Now, if we overflow that though, we'll keep going past 1. So then what we can do is take our modulo, which again, just kind of like as we get to 1, we'll wrap around back to 0. And so if we make our offset Y equal to our move progress T, let's see what that does. Okay, so we go up, 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 wrap back around to 0. So kind of less cool debug visualization than the thing we had last time, but we've got this idea of this animation clip now in our vertex shader. And the important thing is now we can actually use this to drive the animation. So now I think what we need to do is look at these individual segments and figure out how we want these to animate. Here I'll introduce a concept that I use a lot, which is nesting. So this is an idea that within this overall clip, we can kind of nest multiple sub clips almost. So these could be thought of as like each of these individual segments has its own little animation that's nested within the overall crawl cycle. But it's not going to look exactly like this, right? Because there's no overlap here. We're probably going to want these to overlap. So it's going to look probably more like this, where like the first clip plays like that, and then another clip will play, right? And we probably want to be able to tweak these durations to get something that kind of feels just right. So let's say we want to hard code these segment durations like as a percentage of the overall clip duration. And if you think about it, if we do that, it's going to affect the spacing of them quite a bit. Because if we have a really long duration, right, then we're going to have a ton of overlap if we're going to try to evenly space these within the container, right? Whereas if we have these tiny little clips like this, there may even be gaps between them. So the duration is really going to be key for figuring out how exactly we're going to space these inside of this container. And one sort of simple solution for figuring out how we're going to do that is that think about it in terms of the start time of all these things, right? The first thing that's going to play is going to have the exact same start time as this parent. And let's just think about this again in this normalized space from 0 to 1, right? So this first clip will have a start time of 0. The last clip that plays, we know the end time will be 1, which will be the same as the container's end time. So then that means the start time will be 1 minus the duration. So that's how we can use the duration to control the start time. As you can say, the first start time is known, the last start time is known, and then everything else we can just kind of interpolate between those two start times. We just need to know the order they're playing in, but that's easy, right? That's just the order of the segments. So let's try to get that working with like the same type of debug visualization that we currently have, but for the segment progress rather than the overall progress. So what we can say here is we're going to want to visualize our segment progress t. Now we don't have that, so let's try to create that segment progress t. So first let's just say our segment dir is going to be, let's say, 25%. And so then now we have these two different units for duration. So for this one, which is in seconds, let's just add that. And then we can say max start time will be 1 minus our duration, right? And so then our seg start time should be our max start time times some kind of like seg order t or something like that, right? So we just need to know what that order is, and that can just be our segment ID basically. And we just need to get that within a 0 to 1 range in order for this spacing calculation to work correctly, right? So for that, I think we can just divide by our maximum segment ID and see if that works. Now, I think we may have to make one of these a float just so that we get float division there. So we got our start time. So now we just need to get this progress. So we can say segment progress t equals our overall progress minus our start time of the segment divided by our segment duration. So hopefully that was sort of straightforward. And let's just saturate that or clamp it between 0 and 1, right? Our trusty saturate. And let's see what that does. Okay, so that's pretty much working. I mean, it's going the wrong direction, right? Because I think we saw before that our maximum coordinate was on the other side. So let's just say our segment order t equals 1 minus segment order t. And so, yeah, that we're getting now these segments playing with this kind of cascading motion from back to front like we want. And we're still seeing this debug visualization where it goes from bottom to top, but I mean, this is kind of looking cool already. Now let's test out some different durations and see how it affects the spacing like we saw on the whiteboard. So let's try something really big. We'll see that we're barely seeing that cascade because there's so much overlap, right? And if we go down to like some tiny value, we should see gaps between, yeah, right? See? So we're seeing some gaps there. And then if our duration is exactly equal to 1 over our number of segments, we should see them like play all like next to each other with no overlap, right? So one finishes and then the next one starts immediately, right? But I kind of actually like what we had to begin with. So let's just use that. So we get some overlap there, right? But we're still seeing that cascade of the individual segments moving. So I think we're getting somewhere with this move animation. Let's now start getting rid of this fact that we're doing like a debug visualization. Now, I did say we want to have this move up and down though. So let's replace our up and down debug with the real up and down motion, and then we'll get to this forward motion part of it. So instead of what's happening now, which is basically just starting at 0, going up to 1, and then like teleporting back down, what we want to have happen is it starts at 0, comes up to 1, comes back down to 0, right? And we kind of want this arc shape to it. So what does that sound like? This is something we can do with our sine wave. And actually, if I continue drawing this, so we get a full period of this, and remember, 2 pi is the full period of the sine wave. It starts at 0, comes up to 1, comes back down to 0, and then we'll get the part where it goes negative. But it's basically what we want is we want to use our segment progress to drive exactly half of the period, or basically like repetition, the full cycle. If we do half of the cycle of the sine wave, we'll get 0, 1, 0. And we won't even have to do our usual transformation we do to the sine wave because it's already in the range we want. So we can say like our jump t, let's say, is going to be the sine of our segment progress t times pi, which should be half of that cycle, right? So let's make our offset y now this jump t, and let's see what happens. Okay, so this is actually starting to look pretty good now, right? And we could keep tweaking this stuff. And maybe we should actually just, for good measure, give this like an amplitude that we want to add eventually. We can just default that to what it is currently. But we probably want to not just give that raw parameter there, but if we want to change the distance it's moving, let's start taking that into account. The other thing that we need to do also is, like I said, that the front of the body kind of moves differently than the back of the body. I think this will work pretty well for the back, but we want to like cancel this out as it reaches the front. So let's also, in addition to this amplitude, let's get some kind of like back influence t or something. And I think we could actually just use this UVY coordinate, right? Because this is where the maximum of that coordinate is. So we could start with that and then probably add some easing to that, but let's just start with that. Add our influence in and see that kind of goes away. Yeah, so it's still moving a little bit much up front, so let's ease this in, which will make it kind of hug that 0 bound, and that should make it sort of be more at rest in the front. Okay, so let's get started now on the forward motion part, and we'll just start off with these parts that are already moving, and then we can figure out the front part next. The parts that are already moving, if we come back to the whiteboard, as they do this jump up, let's also have them move forward as part of that segment progress. And the amount that we want them to move forward, it should be kind of the same amount that this body overall is moving, because these parts are going to be almost propelling it forward by the same amount the whole body is going to move. So I think what we can say is, let's say like offset z equals segment progress t, and then we want to multiply in some kind of move distance that this caterpillar is moving by, and this is going to be the distance the whole caterpillar moves by eventually, so we can put it up here where the kind of overall stuff is happening and multiply that in. So let's see that, and we didn't actually add this to our world space position, so let's do that. Okay, so now it's happening in the front, so we don't want that to happen. So let's make sure that this also gets our back influence multiplied in. And that's looking better. You can see that it's kind of compressing in the back here because that forward motion doesn't happen in the front. So I think it looks a little weird now, but let's now try adding the overall forward move in. And then as we add that in, we can then kind of get rid of this individual forward motion in the back and decompress that part and see if that kind of looks right. So what we can do is up here, where we're doing sort of the overall moving stuff, we can say like our overall forward move t, and we can just start off with this. Okay, and then here, so right now we're just setting this offset z from this directly, but this is kind of more like the individual segments moves. So let's simplify this a little bit. Let's add these offsets into the world space position as we go now. So we can just do it that way. And so that we don't have to have a single offset y or a single offset z, right? This can be the stuff that happens per segment. And then up here, we can also add to that world space z. So now we can say world space z plus equals our overall forward move times our move distance. And then also down here, we want to make sure that this sort of thing that's compressing those back pieces will get canceled as our caterpillar moves forward in its overall move. So we can say 1 minus our overall move will kind of reverse this backward motion, because remember, otherwise this is going to do 2 times the overall move. So let's see that, and you can see it's decompressing now. Now this is a very like linear motion. We didn't do any easing on that. So let's go in and fix that. We can say like, let's say ease in maybe. See what that does. Okay, that's a little weird. It's weird how it's accelerating into the end though. So I think maybe ease out should work better. And usually this works better for like pushing something, which I think this is kind of what we want to see from the back, pushing the front. And we can make that more exaggerated maybe. And even more. And you'll start seeing there's kind of a problem with this, is that the more we push this, then it doesn't really look like it's actually being pushed by this motion that's cascading anymore, because this overall move is almost happening before this can finish. So we could also take this overall move t, and rather than just doing this ease out on it, we could do something like what we did with our segment and give it like a start time. So we could say like overall start time, right, equals, right, and then we know the overall duration. We could just kind of do that in one line. We could say that this would be our move progress minus our overall start time, and then our duration we can just know is 1 minus our start time. And then let's make sure we saturate, right? And then we can add in some easing. So let's say ease out on our overall forward move. Let's see what that looks like, right? So there's that delay there. And I think it's important because we're just doing a first pass at this, and as we keep modeling this caterpillar out too, we may want to make some changes. So we don't really want to take this too far and polish it, because we're just going to go in and keep changing it. But I do think this may be a good time before we wrap this lesson to introduce our ease in out, because I actually think that might look better than this ease out even. So let's just go back to the whiteboard as the last thing we can do. Take a look at what does this ease in out look like. It's going to look kind of like that, right? It's going to start with an ease in and then end with an ease out. And actually, I drew it like right next to this thing. This is going to follow a similar pattern where if we're less than 0.5, we're going to do one thing, and then if we're greater than 0.5, we're going to do another thing. Remember, this is the same pattern we used for the shape profile up here. So if we want to add that, that's just going to be on our PFX lit surface. And since we're in here, again, I'll just plug that bonus lesson. Since we're getting near the end of this one, maybe you could just go right into that bonus. So let's say ease in out, and we'll just copy this kind of like format here. I'm not going to do this in the most like optimized way. I'll try to make it readable. So we'll say if the value is less than 0.5, we'll do one thing. Otherwise, we'll do another. And basically what we need to do here is just get this value into a range where we can use the easing functions. So that's going to be 0 to 1, and then get it back to the range that it came into this function from. So maybe you'll see what I mean if I could just start doing this. So we'll say val times equals 2, val equals ease in with our ease pal, and then we'll just reverse that transformation, right? On this one, we have to subtract out our start, and then we'll do the same multiplication to get it to 0 to 1, and then we'll do an ease out, okay? And then we just have to, again, reverse this transformation to get it back to the range it came in. So hopefully that makes sense. And now we have an ease in out that we can use in our caterpillar. And let's try that here in our forward move T. Right, so that's a little bit more sort of organic feeling, I think. Now we could keep tweaking this again. I'm going to try to fight off the urge to do that. I think this is a pretty good ending place for our first animation pass at the caterpillar. And I hope you got something out of this. I think the nesting concept will be especially cool once we get these limbs in. So we'll start modeling those next time. And then I'm really excited to see what they look like when they're animated. So hopefully you're getting excited about this caterpillar project. I know I am, and I'll see you next time.